Assalamualaikum and hi. This is our group video assignment for Math 238 Integration by Trigonometric Substitution. We are group 9 from class AS1203C and this is our members including myself, Alia Maisarah binti Azizan, Rabiatul Adawiyah Nawara binti Zulkarnain, Umi Nur Artika Akmal binti Alyas, and Nick Nur Azimah binti Azman. And this is our respective lecturer for this subject, Math 238, Madam Amirahana binti Muhammad. For this assessment, we were given 4 sets of questions to solve involving Chapter 3, Integration Techniques by Use Substitution, Partial Fractions, Trigonometric Substitutions, and for this video group assignment, we were chosen to present the solution for integration by partial fractions and integration by trigonometric substitution. Particularly, for this video 2, we will present the solution for question number 9, integration by trigonometric substitution. And the presenters will be me, Alia Maisarah binti Azizan, and my partner, Umi Nur Artika Akmal binti Alyas. First, let's start with the introduction. What is integration by trigonometric substitution? The function of this integration is to eliminate radicals using trigonometric substitution when we want to integrate functions with radicals. Well, what is radicals? Radicals is an expression that contains square root in it. There are 3 types of radicals using trigonometric substitution. First, for a term of the form square root of a squared minus x squared, we use substitution x equal to a sin theta. For a term of the form square root of a squared plus x squared, we use substitution x equal to a tangent theta. And finally, for a term of the form square root of x squared minus a squared, we use x equal to a secant theta. Then, apply the appropriate trigonometric substitution to a variety of integrals. So, for this solution of question, first we must identify the type of radicals. When we see at the denominator is square root of x squared minus 16, which is the same as the third type of radicals in the slide earlier, which is square root of x squared minus a squared. A is a value of constant. Hence, we will get x is equal to 4 secant theta. From x equal to 4 secant theta, we have to put the power of 2 in all of the forms in it. Hence, we will get x squared is equal to 16 secant squared theta. And finally, we have to differentiate x is equal to 4 secant theta. We will get dx over d theta is equal to 4 secant theta tangent theta. But we have to make dx as a subject. So we will get 4 secant theta tangent theta d theta. Next, for the second step, we have to eliminate the radical. The radical in this question is square root of x squared minus 16. So we can substitute the value of x squared earlier, which is 16 secant squared theta, into the equation. Hence, we will get square root of 16 secant squared theta minus 16. Then, we can factorize it. When we factorize the equation, when we see at the trigonometric identities, secant squared theta equal to tangent squared theta plus 1. Hence, we will get square root of 16 tangent squared theta. And it will be finalized into 4 tangent theta.
My name is Umi Natika Akmal. So today I'm going to present about integration by trigonometric substitution. Okay. So my part is about substitute. After we find the radical, we are going to change the radical into the equations given. Firstly, the equation is integrals 1 over x squared square root x squared minus 16 dx. From here, from the question, we are going to substitute the x squared, the square root x squared minus 16 and dx. We are going to substitute it with the radicals that we find. So firstly, we are going to substitute the x squared with 16 secant squared theta, and then the square root x squared minus 16, we are going to change it to 4 tan theta, and dx we are going to change it to 4 secant theta 4 secant tan theta and d theta. Then we are going to cancel the same one. Okay, first we are going to cancel the 4. Then we can cancel the tan theta and tan theta, and then the secant theta and secant theta. After that, we are going. After that, 1/16 take the constant out of the integrals, and we have 1/secant theta d theta. Then we are going to integrate the 1/secant theta d theta. The integration is going to be like this: 1/16 integrals cos theta d theta. Continue to integrate cos theta d theta. Cos theta d theta, we are going to get a sin theta. So we are going to get 1/16 sin theta. Using the radical that we find, that is x equal to 4 secant theta. 4 secant theta, we are going to draw a rectangle. X equal to 4 secant theta. Secant theta equals to x over 4. X is the hypotenuse over 4. 4 is the adjacent. We draw the right triangle. For here, we label it x, and over here, we label it 4. And then we need to find the opposite one. Opposite one is, we need to open a square root, x square minus 4 square. Then we need to find sin theta. We know that sin is opposite or over hypotenuse. And that means we get square root x square minus 4 square over x. Then we need to simplify it to square root x square minus 16. So from the sin that we get, we are going to put that into the equation that we have, 1/16 sin theta. So it's going to get the last answer, the square root x square minus 16 over 16x plus c.
In conclusion, integration of trigonometric substitutions involves basic simplification techniques. These techniques use different trigonometric identities which can be written in an alternative form. Last but not least, we would like to apologize if there is any inconveniences during our video presentation. And that is all from us. Thank you for watching.